In this video, I will show you how to prove that a quadrilateral is a rhombus. I will also show you how to prove that the diagonals of a rhombus are perpendicular. And if we have time, I will also show you how to prove that a triangle is isosceles, scalene, or equilateral, or a right triangle. Okay, let's start with proving that a quadrilateral is a rhombus. Well, a rhombus is a quadrilateral that has four congruent sides. All right, so the definition of a rhombus is that there are four congruent sides. So keep that in mind. That's why, as far as an introduction goes, I'm going to be finding lengths. All right, congruent means equal length. So I need to find the lengths of all four sides. Now, the main body of my argument really just means clear calculations. Let's find each length. So for example, I'm going to find length PS. Try that again. I'm going to find length PS. I'm going to do this using the Pythagorean Theorem. So if I draw a little triangle where PS is the hypotenuse, then I can do the Pythagorean Theorem. The vertical piece is 1, and the horizontal is, let's see, that's 3, 6, 8. So I have 8 and 1 right there. So that's why I would do the square root of 8 squared plus 1 squared. All right, so that's going to be 8 squared is 64, and then 1 squared is 1. So that's going to be the square root of 65. Okay, now keep that in mind. So let's now find SR. So if I want to find length SR, okay, and again, I'm going to make a right triangle where SR is the hypotenuse. And okay, this is now 4, and this is, let's see, 3, 6, 8. So I've got 4 and 8. Okay, something I'm miscalculating. So this is 4, 2, 4. Okay, so that's 7, not 8. All right, so I've got 4 and 7. So this is going to be the square root of 4 squared plus 7 squared. Well, what is that? So I've got 4 squared plus 7 squared. That is 65. So I've got square root of 65 again. Now let's find QR. All right, the length of QR. And again, it's going to be the same little narrow right triangle. It looks the same as the one up there because I'm going to have a 1 and an 8 again. So of course that's going to be the square root of 8 squared plus 1 squared. Again, I'm going to get the square root of 65. And finally, PQ. All right, length PQ. And if I make a right triangle out of that, all right, similar to what we had going on over here, this is going to be 4, and this is going to be 7. So that's going to be the square root of 4 squared plus 7 squared, which of course is the square root of 65. So you can see that all four lengths are the same, and I'm just going to refer to that in my conclusion. So here's my conclusion. Since all four sides have the same length, PQRS is a rhombus. Now, since PQRS is a rhombus, the diagonals must be perpendicular. All right, this is just something that we memorized. It's the special property of a rhombus that we memorized. The diagonals of a rhombus are perpendicular. Hopefully you did memorize that. So perpendicular. So if I want to prove that two lines are perpendicular, I am going to find the slopes. And when I get down to the conclusion, I'm going to say something about how the slopes are opposite and reciprocal, because that's what it means. That's how we show that lines are perpendicular. Their slopes should be opposite and reciprocal. So in my main body, I'm going to do those calculations. But first, I need to draw the actual diagonals, because some students don't actually know what diagonals are. Okay, so when we talk about the diagonals of a quadrilateral, we are talking about the segment that connects opposite angles. So PR, segment PR is one diagonal. And for example, segment QS is the other diagonal. All right, there are only two diagonals, and here they are. So we need to find the slope of each of those. So let's start by finding the slope of PR. All right, slope of PR. So I could make a giant triangle out of this. Maybe I will. All right, so here's one way to do it. I can make a big old right triangle out of this and just talk about the rise and run from this perspective. I'll have a lot of reducing to do if I do it this way, but this is fine. So let's see. The rise. Well, actually, I should be careful. This is going downhill, so whatever else you do, your slope better be negative. All right, this is going downhill. This is a negative slope. But let's see, I'm going to count. So this is 3, 6, 8. So because I'm going down, I'm going to call this -8. And now going across, I have 3, 6, 9, 12. So this is 12. So rise over run would be -8 over 12, which reduces down to negative, all right, I'm dividing by 4, so that's going to be -2 over 3. So that's slope PR. Okay, now let's talk about the slope of QS. I think I'll just erase this to get it out of the way and make it super clear what I'm doing. All right, so we need to do the rise and run of this guy. Okay, you know what? Maybe I'll do it the other way. I think I'll do it the other way because I want to do the rise and then the run. I mean, it doesn't matter if you know what you're doing, but some kids just get so confused, bless their hearts. So, okay, so the rise. I'm going up 3, 6. Okay, so I went up, so that's a +6. The run is 4, +4. All right, so we're talking slope QS. So rise over run, that's 6 over 4. And that reduces down to 3 over 2. Notice that these are reciprocal, 2/3 versus 3 over 2, but they are also opposite. One is negative and one is positive. Whenever you have slopes that are both opposite and reciprocal, that's how you know that you're talking about perpendicular lines or segments. And I'm going to mention that in my conclusion. So here's my conclusion. Since the slopes are opposite and reciprocal, the diagonals are perpendicular. Okay, let's move on to some simpler stuff. The lengths and slopes of each side of triangle CDE are given. You do not need a graph of triangle CDE to answer this question. So we have the lengths and we have the slopes of the sides of this triangle. Use the information to complete both sentences below. No work needs to be shown. So first of all, is triangle CDE isosceles, scalene, or equilateral? Well, that depends on the lengths. So we should be looking at the lengths right now. It'll be isosceles if we have two sides that are congruent. And that's what we have. These two are congruent. That makes it isosceles. If there had been all three, then it would be equilateral. If they were all different, then it would be scalene. Now, we want to know, is this a right triangle, yes or no? Well, that is going to depend on the slopes. And as we saw, if the slopes are opposite and reciprocal, that makes the lines perpendicular. And that's what you'll have. If you have a right triangle, then that means two of the sides will be perpendicular. So we're looking for slopes that are opposite and reciprocal. I see that we have 7 over 3 and 7 over 3. They are opposite, but they are not reciprocal. If this had been negative 3 over 7, then that would be opposite and reciprocal. So none of these are opposite and reciprocal, right? None of these are reciprocal. So that means that this is not a right triangle, all right? None of the sides are perpendicular, and the only way you're going to have a right triangle is if you have perpendicular sides. Okay, this is a quick review question that has nothing to do with the other topics that we're doing. So I'm just going to knock this out real quick because there is one more question I want to get to that is on topic. So stay tuned for the bonus question in a second. But let's knock this out really quickly. First of all, this is a circle. So if this radius is 5, that means that this radius is also 5. So the question is MN a tangent? Well, the only way it's going to be a tangent is if it is a right angle. And the way we can figure that out is by using the Pythagorean Theorem. So we're going to check and see, does a squared plus b squared equal c squared? All right, does a squared plus b squared equal c squared? All right, question mark. I feel like I should have used a capital D here. Now, as I do this, obviously the hypotenuse here is 13, 8 plus 5. So I'm dealing with 5, 12, and 13. So the question is, does 5 squared plus 12 squared equal 13 squared? Question mark. Does 25 plus 144 equal 169? And the answer is yes, because these do add up to 169. So yes, a squared plus b squared does equal c squared. That means that this is a right triangle, and if you have a tangent line, well, if you have a segment that's perpendicular at a single point, it's going to be a tangent line. So since this fits the Pythagorean theorem, that means that this is, in fact, tangent. Okay, now back to the topic of this unit. Slopes and lengths and that type of thing. All right, so this is the hypotenuse of some right triangle. We have to find the third vertex D and then prove that it forms an isosceles right triangle. Now, you're really going to do a little bit of trial and error to find this point. Now, for example, several students I saw picked this point right here. Now, right away, you know that this is not going to be an isosceles triangle, for example, because if I pick this as the point, I can easily see that this is a length of 4, and then this is the length of whatever this is, 5. This is the length of 8. All right, isosceles means the sides are going to be the same, so this point does not work, so that's automatically wrong. Okay, so you should be playing around with it and looking for some kind of a point where it's going to make a right triangle. Just play around with it a little bit. For example, if I draw my triangle like this almost looks like a right triangle. This is close. All right, I feel like this side is a little bit longer. But if I didn't already know, because I already worked this out previously, I would have to calculate the slopes and lengths and check. But I already did that, and to be honest with you, the first thing I tried was, let's see, the first thing I tried was this point right here. Okay, this point right here was looking pretty close to being a right triangle to me. But looking at it now, I can kind of see that it's a little bit too far to the right. So that one didn't work. And then I went ahead and nudged it over a little bit, and I tried this one, this point right here. And this is the point that turns out to work. So you can kind of just see by looking at it, look how pretty that is. All right, you can kind of see that, yeah, this looks like a right angle. And these lengths do appear to be about the same. But time to prove it. So this is the point 1, -1. And we're saying this is point D, 1, -1. And point F here is the point 3, 5. All right, we're going to need that. And point E over here is the point -5, 1. All right, so if we want to prove that this is isosceles, we're going to need to show that the lengths of the two blue sides here are equal. In other words, we need to find the length of ED, and we need to find the length of FD. All right, if this is isosceles, then these two sides are going to have to be the same. So we would use the Pythagorean theorem probably. So we could easily make a little right triangle out of this. All right, where this blue segment is the hypotenuse. And so we have 2 and we have 6. 2 and 6. So that means the length of ED is going to be the square root of 2 squared plus 6 squared. Well, that's 4 plus 36. So that's going to be 40. So that's going to be the square root of 40. Right? 36 and 4. That's 40. And then we could do the same exact thing on the other side. If I make a little right triangle out of it, maybe I'll do it in purple this time. If I make a little right triangle over here, like bing and bing. All right, then I have a 2 on this side, and then this vertical side right here is 6. So again, because I have 2 and 6, this is going to be the square root of 2 squared plus 6 squared, which is the square root of 40. All right, so this proves that we have an isosceles triangle because same length. All right, now we have to prove that this is a right triangle. So to prove that this is a right triangle, we're going to need to have the slopes. So we're going to need the slope of ED and FD. So slope ED and slope FD. If this is a right triangle, these slopes should be opposite and reciprocal. So now that I'm going to look at this as slope, I'm going to think this is down 2 and right 6. So I'm going to put a negative on this. So rise over run is negative 2 over 6. This is downhill, so just make sure your slope is negative in the end. So negative 2 over 6. Negative 2 over 6. And this reduces down to negative 1/3. Now let's talk about the slope of FD. The rise is 6. The run is 2. So 6 over 2. All right. And this reduces down to 3. Notice that these slopes are opposite. That just means that one is positive and one is negative. And reciprocal. Because this is 1 over 3 and this is 3 over 1. So since they are opposite and reciprocal, that means that they are perpendicular, which means that it is in fact a right triangle.